Hello there, welcome to Divine Gift Lectures. If you're new here, subscribe and also leave a comment and like on this video. In this video, we'll be looking at linear motion. What is linear motion? Linear motion is motion in a straight line. In this topic, we'll be using a few formulae to solve questions. So now, I'm going to be writing them down. And the first of these formulae is V is equal to U plus AT. V here stands for final velocity, or the velocity with which the motion ends. U here stands for initial velocity, or the velocity with which it starts. A is acceleration and T is time. The second equation we'll be making use of here is S is equal to ut plus half at squared. S is distance, U is initial velocity as we have said, T is time. A, as we have said, is acceleration, and T again is time. The third equation we are going to be making use of is V squared equals to U squared plus 2AS. V squared is equals to U squared plus 2AS. V, as we have said, is final velocity or speed. U, as we have said, is initial velocity or speed. A is acceleration and S is distance. Now, we have to take note of something. Acceleration can either be positive or negative. Take note. Acceleration can either be positive or negative. Remember that acceleration is change in velocity per time. Now, if velocity is increasing per time, that is, for example, it's going from 3 meters per second to 4 to 5 to 6 to 7 to 8 per time, then it means that what? Acceleration is positive. If it is negative, it means that velocity is decreasing with time, for example, from 8 meters per second to 7 to 6 to 5, and it keeps going down. That's negative acceleration. So acceleration can either be positive or it can be negative. Now take note that in vertical motion, in vertical linear motion, acceleration is equal to acceleration due to gravity, which we represent as g. Acceleration is equal to acceleration due to gravity, which we represent as g. Vertical motion is motion, for example, from up to down. So a motion that's like this is what? It's vertical motion. Okay? So take note of that. Now, in solving questions on linear motion, we make use of three basic steps. We make use of what? Three basic steps. The first of these steps is to note down, capital letter here, note down all the parameters given. Note downwards all the parameters given. Number two is to make inferences. Make inferences. Number three is to choose a suitable formula. So these are the three basic steps to solving any question at all under linear motion. So I'll be using these questions to show you how to solve questions on linear motion. Now, this question says a car moves at 5.0 meters per second. If it subsequently speeds to 6.8 meters per second in 3 seconds, calculate its acceleration. So now we're going to be making use of the three simple steps I've given you. And the first is to note down all the parameters. Now they said a car moves at what? 5.0 meters per second. And then it subsequently speeds towards 6.8 meters per second. This means that its initial velocity is 5.0 and its final velocity is what? 6.8. So we have U is equal to what? 5.0 and V, which is final velocity, is equal to 6.8. Now, what else were we given? We were given what? Time. And time here is what? 3 seconds. Or no need for the formula yet. And no need for the units rather. Then, what are we looking for? We are looking for acceleration. So we are also going to note that down as a question mark. We don't know what that is. That's what we are going to find. Now, number 2 says make inferences. Now, in this case, we don't need to make any inferences at all. And in question number 2, I'll be showing you how to make inferences. So we'll be going over to the third step. which says we should choose a suitable formula. Now, how do you choose a suitable formula? You choose a suitable formula by looking at the parameters you have, and then you look at the formulas that you have and check which formula here has all of this and just this. Which formula has all of this and just what? This. And we'll find out that formula number 1 is appropriate. So we are going to make use of that. V is equals to what? U plus AT. So with that, you start solving. So now we put in V, which is 6.8, okay, is equal to 5.0 plus A, we are looking for A, and T is 3. So we have 3A. Now we collect like terms. We bring 5 here and it becomes negative. 6.8 minus 5.0 is equals to what? 3A. 6.8 minus 5.0 is 1.8, which is equal to 3A. Divide both sides by 3 to leave 8, and that will give us, this will give us what? A is equal to 0.6. Remember, something is missing here. You have to put the units per second square. So please note, your unit is always important. So that's the answer to question number 1. Now looking at question number 2, they said an object starts from rest with a constant acceleration of 15 meters per second square along a straight line. Calculate A, speed at the end of 5 seconds, B, the average speed during the time interval, the distance traveled in the 5th second. Now because of space, we are going to be making use of this space to solve it, and after that, when we want to solve the match field, we fill them. Now an object starts from rest with a constant acceleration of 15 meters per second. So we are going to follow that 3-step process, and we are going to be taking note of the parameters we are given. The said acceleration is what? 15 meters per second. So per second square along the straight line. Calculate the speed at the end of what? 5 seconds. So the time we are given is 5 seconds. And for question number 2A, they said what? Calculate the speed. So it's the speed you are looking for. Remember, we always also take note of what we are asked to look for. So we are looking for final velocity because they said speed at the end, that's final velocity. Now we're going to look at number 2, which means we should make inference. And making inference, we are going to make an inference here, and we are going to see that what? They said starts from rest. Starts from what? Rest. An object starts from rest. Now take note, whenever they say start from rest, it means that the initial velocity is 0. If they say start from rest, it means that the initial velocity is 0. But if they say it comes to rest or it comes to a stop, that means the final velocity is 0. So in this case, they said start from rest, meaning that our u is going to be what? U is going to be 0. So now we've made inference. That's how to make inferences. Now we are going to go over to the third step, which says we should choose a suitable formula. So now we are going to use a suitable formula and see which formula has all these things in it. And we are going to find out that again, it is formula number 1. So that will be V equals to U plus AT. So then we start solving. V, what we are looking for, is equals to U, which is 0, plus A, 15, times 5. V is equal to 15 times 5, 0 plus 15 times 5, which is 75. V is equals to 75. Remember to put your units meter per second. So this is the answer to question number 2A. Now going over to 2B, they said the average speed during the time interval. Now, what's the formula for average speed? Okay, we didn't note that down, but let's note it down now. Formula for average speed or average velocity. Average speed or average velocity is equal to what? V plus U, or let's put it the first, and that's initial velocity plus final velocity all over 2. So take note, average velocity is equal to initial velocity plus final velocity all over 2. Now they said during the time interval. So during the time interval, the initial velocity what? Starts from rest, which means 0. And then we found that through question A that for the final velocity in the time interval is 75. So we can say the average velocity of speed is equal to what? U plus V all over 2, which is equal to 0 plus 75 all over 2, and this will give us 37.5 meter per second. So these are answer. So anytime you want to solve questions on average velocity, you just use this formula. Now going over to C, the distance traveled in the 5th second. Now I want to explain something here. Please, this is not after 5 seconds. This is in the 5th second. So I'm going to explain something. Now take note. For example, when you are born, at that time you were 0 years old. That day you were born, you were what? 0 years old. But now, after your 1st year, you became what? 1 year old. After your 2nd year in life, you became 2 years old. After your 3rd year, you became what? 3 years old. Now this shows that your 1st year is between what? 1 and 0. Your 2nd year is between what? 2 and 1. Your 3rd year is between what? 3 and what? 2. Now also take note. Remember when they say 17th century, 18th century, 19th century. When they say 17th century, they are talking about years like 1622, 1689, that's 17th century then. If they say, for example, the 20th century, they are talking about 1905, years like this, 1986. Have you ever asked why? 17th century this, 20th century this. Now, this shows that it proves this point again that the 17th century, that is 17th century, is the century that's between what? 1600 and 1700. So anywhere here is 17th century. That's why years like 1622 is 17th century. 1689 is 17th century. Now, the 18th century will be what? Guess. It will be what? The time interval between what? 1800 and 1700. So this is what? The 18th century. So if you want to call years in 18th century, you don't say 1820. No, this is out of it already. What are the years in between here? The years in between there are what? 1736. Because here we can have 1736, 1799. These are what? Years in 18th century. This is also why they call the century we are in now the 21st century, because it is between 2000s and 2100s. That's why it's called the 21st century. So take note. Now, this also means that if they're asking for the distance traveled in the 5th second, it means that they are asking for the distance traveled in between just what? Between when it was 4 seconds and when it was 5 seconds. So this is the distance they are asking for. They are not asking for after 5 seconds, no. They are asking for example, when you put your clock on, you see it reaches 4 seconds, then just calculate the distance you traveled in between what? 4 seconds and 5 seconds. So how do we find this? We can find this by calculating what? The distance traveled after 5 seconds. That is, let's say this 0 to 5. Let's say 4, 3, 2, 1. Distance traveled after 5 seconds. Then minus the distance traveled after 4 seconds to find the distance traveled between 4 and 5. So take note of this. Remember, anytime they ask questions like this, distance traveled in the 5th second, in the 4th, in the 7th, you use the second formula, which is S is equal to UT plus half AT squared. So we are going to go back to solving this question. Remember, the formula is S travel, see distance traveled after 5 seconds minus distance traveled after 4 seconds to give you distance traveled in the 5th seconds. In the 5th second rather. So take note. Now we are going to do what? Put in the formula. That's ut plus half at square. Square minus ut plus half at square is equals to s/5. Okay, so now let's look at something. Initial velocity was what? In this case it was 0. All right, so that means 0 time whatever the time is at all is going to be 0. So it means that this will cancel out. Okay, this will cancel out. All right, so we can just say, or let's just put it in, and then since these two are already 0 because u is 0, anything 0 multiplies 0, so we are just going to have half at 5 minus half at 4 is equals to s/5. Okay, so now we are going to put in our values and solve. A is 15 times t is 5 minus half 15, that is times 15. Okay, 1 times 15 times 4 seconds. Okay, s/5. Okay, so this will give us 2 going to this. This will give us 15 times 2. Sorry, remember square. Forgot about that. So 5 square, 4 square. 4 square is 16. So this at the end of the day will be 16. 5 square is 25. So this at the end of the day will be what? 25. 2 into 16 is 8. So we have 15 times 8. Then 15 times 8, okay? So I'm going to take it over. This process to be 8. So we are going to take it over here. And 15 times 8 is 120. To solve all these, this will give us 7.5. And then this will give us 187.5 equals to s/5. So if you calculate this, this is what it will give you at the end. So now this will give us 67.5 meters. That is for the distance traveled in the 5th second. So we have the answer 67.5. So take note. This is how you solve the question anytime they ask you calculate the distance of the 5th and found in the 5th second and all that. So you always make use of this formula. Alright? So take note. Now we are going to quickly go back to the next question, which is number 3. And it says the speed of a truck is reduced uniformly from 9 meters per second to 7 meters per second while traveling a distance of 10.0 meters. A, what is the acceleration of the truck? B, how much further will the truck travel before coming to rest? We are going to use the 3-step process. So we are going to say, look at this, reduced uniformly from 9, and that means initial velocity is 9 to what? That means initial velocity is 7 because it's reduced to 7 meters per second while traveling a distance of s is 10. Okay. Then A, what is the acceleration? So this is what we are looking for. So we've noted down all the parameters. No need to make inferences here. Just choose what. The next thing we do is to choose a suitable formula. And in choosing a suitable formula, you find out which formula has all these things I'm going to use. And that's number 3. So we are going to have v squared is equals to u squared plus 2ax. Now, v squared is what? 7 squared, u squared, 9 squared, plus 2 times a times 10. 7 squared, 49, 9 squared, 81, plus 20a. Now, collect like terms, CLT, 20a is equals to 81 minus 49. 20a is equals to 36. Sorry, is equal to 32. Yes, 32. Divide both sides by 20, and this will give us 32 all over 20, and this will give us at the end of the day 1.6. Okay, so remember, okay, there was something here. Remember that what 49 moved here, and when plus 20 moved here, it became minus. So please take note. So minus 1.6 meter per second square. Why is there minus here? Because 20a moved here to become minus 20a, and 49 moved here to become minus 49. So take note. How did I know that there was something wrong? Because they said it was reduced, and I told you that whenever velocity reduces per time, acceleration will be negative. So if in this case where they said reduced and your answer is positive, there's a mistake. So take note. Now B, how much further will the truck travel before coming to rest? So they are asking for what? The distance before what's coming to rest. So now we are going to need new parameters, because now the points, they say how much further. The point they are starting from is from where velocity became 7. So in this case, our u is going to become 7, because they say how much further. So the point they are starting from is from the point where it became 7 meters per second. So our u is going to be 7 meters per second, because that's the point they are starting from now to calculate the distance, because they said how much further. Now, acceleration, they said is constant, so our acceleration is still 1.6. Now, also, what are we looking for? S. We don't know S. And they said what? Number 2, which means make inferences, comes to rest. And if it comes to rest, it means its final velocity is 0. So now, which formula has all these things here? And we find out that, again, it is what? The third formula. So we are going to make use of that. V squared is equals to u squared plus 2as. So now we are going to solve. 0 squared is equals to 7 squared plus 2 times minus 1.6 times s. 0 squared, which is 0, is equals to 49. 2 times minus 1.6 is minus 3.2 s. Bringing this over here, we have 3.2 s is equal to, minus becomes positive, so 3.2 s is equal to 49. Divide both sides by 3.2, we have s is equal to 49 all over 3.2. Okay, and this gives us at the end of the day, it gives us 15.3 meters. Please don't forget to put down your units. So at the end of the day, we have that the answer for B is 15.3 meters. So I hope you enjoyed this video. If you enjoyed it, please leave a like, leave a comment, and don't forget to subscribe. See you in my next video. God bless you.